Welcome. My name is Ben Tissio. I'm an architect and an adjunct professor at Lawrence Tech. And today I want to go over building codes and regulations. One of the first things that you will do as a designer is start designing the building. But before you do that, you have to make sure that the property is zoned for its intended use. The Michigan state law requires that all municipalities, governmental agencies, have to have a zoning map, and each parcel of property has to have a specific zoning. It would be residential, commercial, industrial, public land. All of that has to be shown on a zoning map, as it's called. This here is an example of the Southfield zoning ordinance map, and it shows all the zoning districts that are within the city limits. Lawrence Tech is right here, and you can see all the different types of property zoned. You can see there's a lot of residential, but in these major thoroughfares, they tend to be for industrial or commercial use. Same thing along 8 Mile Road. And then they typically all have a legend that shows the districts and also the titles. Residential is usually designated as an R, 1 through 3, 4, or 5. Then you get into other ones, like here business is a B1, B2, and usually that gets into its density and its height of the structure. The ordinance usually indicates the type of business that is allowed to be built or function on that property. So those are called permitted uses. They also have waiver uses where you can use them, but you have to present your case to the city and they will give you approval. Then they, in a lot of cases, they also indicate prohibited uses. Things like stores that sell alcohol can't be within 1,000 feet of a school property. Things of that nature. That's designated in the zoning ordinance. The ordinance covers the property itself, not so much the building type or design. However, there are some design features that this ordinance will specify. The ordinance will specify the maximum size of the lot, the building setbacks, the minimums, be a front yard, side yard, or rear yard, building heights, and parking requirements, as well as landscaping requirements and signage and so forth. So we'll get into sometimes the material of the property, but it is mainly dealing with the site uses. So once you've mastered that, then you start looking into the building code. The reason the building code is important is because you need to understand the design parameters of the project before you start actually designing the building. The worst thing you can do is start designing a building and you make it 6 stories, and then you're halfway through the design and you realize the ordinance only allows 3 stories. You're going to have to trash everything and start all over again. So you need to be careful that you understand all those parameters. The same thing with the building code. You may design a 6-story building of a certain construction type, but the code doesn't allow you to build it in 6 stories, and you're going to have to change things. There's been a lot of projects that have been rejected at the building department because they lack egress requirements or fire ratings, and all of a sudden now the project is delayed and it costs you money as well as embarrassment. This is not something new. Society has been concerned with building codes for many, many years, actually centuries. The first known building code is King Hammurabi. He was the king of Babylonia in 1759 BC, and he had a requirement in the codes that if a builder built a building and it's not strong and killed the owner of the builder shall be put to death. It goes on to further say that if it killed the death of the son of the owner, the builder's son shall be put to death. If it cut off the arm of the owner, the builder's arm shall be cut off. So it's literally an eye for an eye. So they've had problems with safety on buildings for many, many centuries. Bringing it up to the modern age, there was a great fire in London in 1666, and it burned down almost all of the city. So the solution that the City of London came in with, they took the city and they broke it up into different quadrants. And I doubt that it was a square, something like this, but the whole idea was that they broke it up into different areas. And what they said is that if your property falls along one of these designated areas, they had to be built of a certain type of construction. And typically it would be a non-combustible construction. So along these major thoroughfares, you could not build buildings made out of wood framing. So therefore, they had to be either usually a concrete or some kind of stone structure. In between, they could be wood. And the whole theory behind it is if there was a fire, it would be limited to that fire area within that city area. And I don't know, it varied probably from a square mile to maybe 2 or 3 square miles. But it wouldn't devastate the whole city as it did in the Great Fire in 1666. Coming closer to today's time and in the United States, there was the Chicago fire. I'm sorry, the fire was in 1871, excuse me. And as a result of the fire, the insurance companies had to come up with payments to the building owners so that they could rebuild their buildings. Well, the insurance companies got together and they said, you know, we can't have these owners building these fire traps as they had before. So let's come to an agreement. So they sat down with the developers or the owners of the building and said, listen, we will give you the money back on the insurance on the building if you agree that what you will build would be will conform to some fire regulations and safety exiting requirements. That was proposed in 1871. It took a little time, about 4 years. Finally, the developers agreed to it and the owners agreed to it. So in 1875, they had the code from the insurance company that required these homeowners, or I'm sorry, these builders and owners to build buildings out of these non-combustible materials. The first modern building code was in 1923, and that was the National Building Code. There was 3 others. In 1927, the Uniform Building Code was introduced. In 1940, the Standard Building Code was also introduced. And in 1950, the BOCA Building Code, which is the primary code used in the Great Lakes area. And for years there were differences between those 3. And then as it goes, there were some complaints to the U.S. Department of U.S. Department, and they said, you know, this makes no sense that these building codes are so different. I don't understand why they can't have one building code. So they kind of pushed the 3 organizations into a position where they had to merge, and they did merge. And in 2000, they came out with the, in the year 2000, they came out with the International Building Code. And that was a national publication and covered the whole state of the Union, all 50 states plus the other jurisdictions, and that it is adopted by almost all those municipalities currently. I was a little surprised when it took place because I doubted that the 3 organizations could come to a consensus on what this code would look like. But what they did is they took certain chapters in the code book, and they, from the Uniform Building Code, they took another one from the Southern Standard Building Code, then they had another one from the BOCA Code, so they merged all of them into the 34 chapters that was published as the International Building Code. This made life a lot easier for us architects, simply because now we had a one uniform code to work from. And each of these codes now come out in 3-year cycles. So it started out as a, they came out with the 2000 International Building Code, and it went every 3 years since then. The current edition right now that is in use in most municipalities is the 2012 International Building Code. There is a 2015 edition, but that's not been adopted by anyone yet. There are some communities that still have their own building code. By example, Chicago has its own building code. They did not adopt this. The Chicago Building Code is based on a 1948 edition with multiple revisions to it. The Dade County in Florida has its own building code. So if you're not going to use this, you're going to use the community's building code there. The codes are intended to do one thing, and that is to build safe and economic buildings based on acceptable standards. It is not to build the most safe building possible, because that is not possible. By example, in this part of Michigan, we designed the roofs for about a snow load of 25 pounds a square foot. Whereas in the UP, you're designing the roofs for about 90 pounds a square foot. Is it reasonable then to add a snow load in this part of Michigan for 100 pounds a square foot? No, because we would never approach that. So again, it's the reasonably safe requirements, not the most safe design on the building. I know that structural is another thing. I mean, do we design the building to withstand a force from a tornado that picks up a telephone pole and hurls it at a building at 250 miles an hour? Well, you probably have to have 4 feet of reinforced concrete walls to withstand that force. Buildings are not designed for that, nor should they. So there's a reasonableness to the code requirements. So far it's proved itself. And also the code will try and not get too descriptive, because they want the architects to use their imagination to solve certain problems. By example, they will give the performance requirements on structural elements, such as a 2-hour fire rating on a wall, or a floor-to-ceiling fire rating of 3 hours. To some degree, they don't care if you build it out of peanut butter and celery, as long as you get it a 2-hour or a 3-hour fire rating. So it's trying to allow the design professional to use their imagination to come up with these solutions. Otherwise, we'd be all building buildings out of stone and masonry, as they did for many years. A little bit of history on the Michigan Building Code. In Michigan, there have been mainly 2 codes, the BOCA Code and the Uniform Building Code. And some communities had their own. By example, Dearborn had its own building code, and so did the city of Detroit. And then that all changed in 1972 when the state law passed that required that all municipalities have a national, adopt a national model code. So that meant, really because of the part of the country we're in, either BOCA Code or the Uniform Building Code. And most communities adopted the BOCA Code. And then in 2001, the state law changed. And that's when the state law required that all municipalities in Michigan, without exception and without modification, had to go along with the state's code, family of codes, which included at that time the 2000 Michigan Building Code, Michigan Residential Code, Michigan Plumbing Code, Michigan Electrical Code, and Michigan Mechanical Code. So it was a whole family of codes. I know there was some resistance to that at first, but after some arguments with the city of Detroit and the state and Dearborn, they decided to frankly not fight the fight and go along with the new state law that required them to comply with the state code. The municipalities are responsible for the plan review if they have the certification to do that. Otherwise, the state of Michigan will also do that, as well as the inspections if you ask. Other codes and regulations that architects and engineers need to abide by, as I mentioned, the mechanical code, plumbing code, electrical code. There's also the energy code. We have a Michigan energy code. One is different for residential versus, and when I say residential, I mean 1 and 2 family. And the other one is for commercial. We have the MIOSHA, the Occupational Worker Safety Code. We don't get involved in it too much other than the requirements for ladders on accessing building for some reason are in the OSHA code and not in the building code. Michigan Barrier-Free Design Code. We'll talk about that in a minute. The American Concrete Institute has standards. American Institute of Steel Construction, ASHRAE, Underwriters Laboratory. So there's a lot of other codes and regulations and standards that we need to follow. One of the important ones that came up actually nationally was the disability or the handicapped people. The primary disability addressed in the code is the walking impaired or people that are in wheelchairs. But it also addresses 2 other key components, and that is the seeing impaired and the hearing impaired. Even though there are less requirements, nevertheless they are also have to be addressed. The disability requirements for our purposes start at the right-of-way that goes into and through the building. The reason is that inside the right-of-way you have no jurisdiction over that. That is the jurisdiction of that municipality or a state or a county. And you have no authority to do work in that area without their approval. So they take that requirement from there, and you take it from the property line into and through your building. Then it addresses parking spaces, entrance to doors, all the public areas in the building include toilet rooms, and even the exit. In Michigan, there was a law passed in 1966 that required all governmental buildings to comply with barrier-free design. So that meant you had to have ramps in the buildings or no steps, and you had to have public facilities, you had to have doors a certain width, etc. Parking spaces with signage, all of that was required for all governmental buildings starting in 1966. In 1976, the law in Michigan was expanded to include commercial buildings. And again, this was for all the commercial buildings in Michigan, not 1 and 2 families. Then in 1990, then President Bush, that would be senior, signed into law the Americans with Disabilities Act. And that was a rather wide sweeping law that required that all buildings built to a disability standard. In this case, it's called the American with Disabilities, or ADA, as we now know it. It took 2 years to go into effect because it wanted the owners and architects and others to basically get familiar and have some time to implement it. I believe it was in June of 1992 is when it actually went into effect. An interesting story is that that was actually on a Sunday, and that Monday morning there was a lawsuit filed against the owners of the Empire State Building because they didn't comply with the American Disabilities Act. The observation floor and the gift shop floor were not accessible by people in a wheelchair. I remember that because I called the attorney that filed the lawsuit in New York, and I was speaking to her, and I at some point in the conversation I asked her why the Empire State Building. She says, what better building does everybody know in the United States? The Empire State Building. So we took it to make a statement. And sure enough, about a year or so later, they settled the agreement, and the owners agreed to renovate the gift shop floor area and the observation deck to allow people in wheelchairs to access those decks. So it worked. The thing that you need to remember is that the American with Disabilities Act is federal civil rights legislation. It is not a building code. Therefore, it's only enforceable in the courts. If there's an issue with accessibility in a building and you want to get in compliance with the ADA, you have to file a lawsuit in federal court, and then the court will decide the merits of the case, not the building official. Barrier-free design is a Michigan law, and that's the building official's area responsibility. So there are differences. The other big difference in the American Disabilities Act is that where the building code mainly addresses new buildings, the American Disabilities Act also addressed existing buildings. So if you had existing buildings, you had to then renovate your buildings to comply with the American Disabilities Act. And that meant providing parking spaces with certain widths and striping and signs, having curb cuts so people in wheelchairs could come up on ramps, changing the door widths of your public areas. So it had an implication, and there's been many, many lawsuits as a result of that. And again, all this information is available on the ADA website, ada.gov, and you have the whole standard. The current standards is the 2010 standard, it's design standards for ADA. It's free. I highly recommend you download it and use it, because I use it in my office almost daily in the design of the buildings I work on. A little bit about architects and engineers. Architects and engineers are licensed for one reason, that's to protect the public's health, safety, and welfare. It's not to design award-winning buildings. The whole purpose of any law is to protect the public's health, safety, and welfare. There are 54 jurisdictions in the United States. The 50 states, District of Columbia, you have also Guam, Puerto Rico, and the Virgin Islands. All of those come under the jurisdiction of the United States, and they all have different licensing requirements. Each of those states or areas has their own licensing law. There is no such thing as a universal or statewide licensing law. There's an individual state licensing law. I happen to be licensed in 10 states. Michigan was the first state that I was licensed in. I can be and have been licensed in other states through a form that's called reciprocity. I will make an application for the state of Virginia to be a licensed architect in that state. I fill the form out, I contact NCARB, they send my file to that state, and that state reviews it and will grant me the license. And it varies anywhere from literally a few days to a few months. It all depends whether it goes before the Board of Architects or they can review it administratively. But the one catch is you always have to pay for this. By example, it costs me $400 every time I have NCARB send my file to a state that I'm applying for. And the application in any state varies from $50 to $400. So it's easily, you can rack up, by the time you buy your seal and everything else, $1,000 to be licensed in a particular state. And the purpose of that is that once you do the documents, that when you submit them for the building permit or any other review by a municipality or governmental agency, it requires that you place your seal and signature and date adjacent to that. Now, the one important thing that you have to understand is that seal has your name on it, not the company's name, that has your name on it. And what that means legally is you become personally liable now for that work. So that my seal says Benedetto Tissio. I sign it, that means I am personally responsible. If I do something really wrong, the courts can come in and take my house, my car, because I'm personally liable, not just the company. So that's an important thing to remember when you get your seal and when you use it. Now let's get into some of the real heart and meat of the building code. Okay, so let's start in with the building code. We'll be working with the 2012 International Building Code. And one of the very first things that you need to do when you're dealing with the code is establish what's called the use group. And in the code, there are 10 uses. Let me make sure I get them all proper. And they usually are all designated by a letter first and then its actual description. Those are the 10 uses in the building code. And most buildings are going to have some combinations of these. But the primary use, by example, assembly is broken up into an A1, A2, A3, A4, and A5 use. Restaurants fall in an A2 use. Houses of worships are an A3 use. You have movie theaters, you have stadiums like Ford Field that are enclosed or under one category, and Comerica Park that are open, they fall in another category. But those are assembly, and those are typically reserved for a very large number of people. Usually the magic number is 300, although you can have smaller people in assembly uses. By example, restaurants. A lot of restaurants have 100 or so people, maybe 150. So that's an assembly use. A business is, like the name implies, a business. An architect's office, a doctor's office, an attorney's office, or a business unit. Educational is a K through 12. Doesn't include universities or colleges. This is only for K through 12. Factory industrials, like the name implies, it's manufacturing of products, whether it be cars or wheels or radios or anything of that nature. High hazard are typically structures that work with high hazard materials. Battery acid, chemicals, tires, something that is a high hazard. Institutional, hospitals, prisons, things of that nature. Those are a different use. Mercantile, that usually covers things like shopping centers, whether it be malls or strip shopping centers, or even some other types. Residential is the non-1 and 2 family, so it would cover the multi-family type of businesses. And those have multiples, R1, R2, R3, and R4. As well as a high hazard has an H1, H2, H3, and H4. Storage are, like the name implies, they're storage of materials that aren't high hazard, as the name implies. This is simple storage, warehousing, and so forth. Utilities is kind of a catch-all. They'll take things like water towers and things of that nature, substations for phone companies, for utility companies. Those are under the utilities. So the first thing you need to do is establish what is the use of this building, or in some cases, uses of the building. And once you do that, then you need to take a look at what are the limitations on the structure. And then you get into what is referred to as Table 503, the allowable building heights and areas. And you'll notice that it has 5 different types: Type 1, Type 2, Type 3, Type 4, and Type 5. And then those have subcategories: A, B, A, B, A, B, A, B. There's no subcategory here, and A, B, and A, B here. This is always not an easy table to understand. Let me see if I can give you some history on this. Before all of this came about, there was a method of construction. It would be wood, heavy timber, you had basically masonry, steel, and concrete. And this table has to do with the limitations of the size of the building, both in floor area and in height of the building. Why is that important? Because of the fact that you don't want to be building a structure that's going to house 500 people viewing a movie theater, filming a movie theater that's made out of wood. That's an extremely hazardous condition. If there's ever a fire in that space, the building is going to burn very quickly, and a lot of people are going to die. So the code went back and says, okay, you want to build something out of wood? Well, here's a limitation on the size of the area for each floor and the height of the building. So the same thing is true on all of these. So this was usually the basics of what they started. Then they got a little more sophisticated in the code, and then they made changes. Well, let's make it a type construction. So rather than deal with the wood, the heavy timber, the masonry, steel, and the concrete, they went to what they have now on the table, of a type 1, a type 2, type 3, type 4, and type 5 construction. And it goes in just the reverse. Type 1 is basically your wood frame. This is your heavy timber, that's what the HT is for. Type 3 is your masonry and steel in limitations, and type 2 is masonry and steel also, and type 1 is basically a concrete. And what you do here is you go down the group, or the use of the building. This is actually on 2 pages in the code. I just copied the front page. And here's your 5 different assembly uses. Here's a business use, education use, factory uses, 1 and 2. High hazardous uses, 1 through 5. Institutional, 1 through 4. And in this column it tells you, in this row it tells you the limitation on this height in feet. So if you're building a type 2B construction, the maximum height of your building is 55 feet. Same thing if it's a type 3, it's a 55. If it's a type A, it's 65 feet. If you're doing a type 1 construction that usually has 4 hours and 3 hours of fire rating and all the structural elements, the height of the building is unlimited. That's what the UL stands for. Again, the greater fire protection of the structure itself will give a greater fire protection for the occupants of the building. Therefore, you can make it bigger. That's the theory in the code. Excuse me. So that if we look at a business use, and we want to build it out of a type 3B construction, what we're limited to is 3 floors in height and no more than 19,000 square feet per floor. So each floor can be 19,000 square feet in a 3-story building. The 3-story building includes a basement. That is a floor or a story as is defined by code, even though it may be below grade. But there's a lot of nuances in the definitions of a lot of it. It's gone through many years of interpretations. So then you need to see that, what is your construction going to be? So if you want to build a hospital, then you're going to have to look at something that is in a type 1 or type B construction. And once you establish that, then you work with here, this is table 601. And these are the basic structural elements of a building. So if you happen to have a building that is a type 2 construction, and you're looking at the primary structural frame, in this case, everything is a 0. That's why a lot of buildings are built of the type 2B construction. But you're limited to its size again. So if you want to really have a tall building that has a lot of footprint or a lot of height, then you're going to have to look at something that's much greater. In this case, you have a type 1 construction. If it's a 1B construction, the primary structural framing members, the steel columns and beams, have to have a 2-hour fire rating on them. The exterior walls have to have a 2-hour rating. The non-bearing walls, 0. Floor construction, from floor to roof, floor to floor construction, that is a 2-hour rating. And then the construction of the roof construction is a 1-hour rating. But you're going to add fireproofing around these constructional elements, but it allows you to build a building that's much taller than you would have done under a type 2B construction. And you can see the difference here right away. If I'm going to do this in a type 1B construction and I'm a business, I'm unlimited, I can go up to 11 stories here, where here I can then go 3 stories. And my floor area per floor is unlimited. So I can make the building, 400,000 square feet of floor, up to 11 stories in height. So using the code to protect the building allows you, the occupants allows you to have a much bigger building. And that's kind of the analysis that we do when we start to look at structures as to what is it. First you have to establish the use group, and then you have to establish the actual construction type, because then that allows you to move further into the code. Now, the exterior wall construction is defined in table 602. All right, let's take a look at this, what this means on table 602 as far as the exterior walls. what they're looking for is if you have a property line and you have a building here. What they're also looking at is the fact that there's probably going to be a building on the adjacent property that you have no control over. So therefore, they need to look at what is the requirements for your building. And it gets into these different categories. And what that is discussing or indicating is what is the difference from the property line to your structure. And the categories are from less than 5 feet, 5 feet to less than 10 feet, 10 feet to less than 30 feet, and more than 30 feet from the property line. And this gets into, here we go again, the construction type. These are all construction types in this first category. Second one is 1A, as well as others. 1A, 1B, 2B, 5A. And by the way, you notice they use Roman numerals. Why? I don't know. It's difficult to read sometimes, but that's what they have. And then all again here. So, and these are the use groups. You notice in a high hazard use group, if you're 5 feet with your building to the property line, that exterior wall that we're talking about here has to be a 3-hour fire rated wall. And what they're worried about is that the fire from this building will go into the next building or vice versa. It could go back into this building. So that's why you have a 3-hour fire protection on that exterior wall adjacent to the property line. If you go into other occupancy, you'll notice 2 hours, 0. But the majority of them are a 1 hour, or in this case, if you're between 10 and 30 feet in a type 2 and a type 5B construction, it is a 0 rating. If you're more than 30 feet, it doesn't make any difference. There's no requirement for that. So that building has no fire rating if you're 30 feet from the property line. Okay, again, it's to stop the prevention of fire from going from one property to another property. That's the purpose of this table 602. You're also allowed in the building code to have what's called a height and area increase. And there are multiple ways of accomplishing that. This goes above and beyond what's in table 503, 19,000 square feet for that building. Well, all of a sudden, if you put a sprinkler in a building, you're allowed to increase the building, if it's a single story, by 300%. So that means you can go 19,000 square feet plus 19, 19, 19. That's the maximum area by simply adding a sprinkler system. The code is very variable, very favorable to sprinkler systems, so that you can gain a lot by doing that. It also allows you to increase the building by 1 story. So instead of a 3-story building now, you can go 4 stories by adding a sprinkler system. Also, there's an area increase, and that allows you that if this is your building, there's a formula, and that if you are 20 feet plus from the property line, you can increase the building by this wall. And if you have it on other parts, then fine. But if you have it on one side, it's only 5 feet, you can increase it. But the purpose is that this increase is it allows the firefighters to go around the building. So you can also get up to a 75% increase by having an area increase with 20 feet or more around the whole perimeter of the building. One thing that the code is very diligent about, and that is on the occupancy load on different buildings and different uses. And the means of egress, this is table 1004.1.2. The code will define for you in the use of the space by example, in educational spaces, which would be obviously Lawrence Tech, in classrooms, there is one person for every 20 square feet of floor area. So it's easy enough to design a classroom, and you compute the floor area, and you can determine the number of people in that area. Same thing with where our looking for, okay, mercantile spaces. Great floors, one person for every 30 square feet of floor area. If you have a stock room, it's one person for every 300 square feet. So the code requires you to use this table as a method of defining what are the number of occupants that can be in each of those spaces, as well as the whole building. That's important because you have to know the capacity of the exit number, the number of exit doors, as well as the length of travel and so forth. So let's talk about egress, because that's one of the big items in the code, and that usually is something that a lot of architects and especially students will trip on. There is a means of egress. It's a definition in the code. There are three parts to a means of egress. There is the exit access, the exit, and the exit discharge. I take a building. This is in plan. And I have a series of rooms and offices on this floor plan. This is my stairs. This is my corridor. The exit access is from any point in the building to an exit. This stairs is an exit. It's just the stairs is another name for an exit. And then once you get down your stairs, you come out the door to the property line. That's the exit discharge. And that's the public right of way. Basically the sidewalk. You have to get the occupants of that building from any point in that building safely out to the public right of way. And then the municipality or the jurisdiction will take care of the people from there. So those are important because those are defined in the code, and throughout the code they will talk about exit requirements, it'll talk about exit discharge, it'll also discharge, it also will talk about all those requirements and lengths and travels and so forth. Exiting requirement, kind of a rule of thumb, the code gets into more detail, but when you have number of exits, this is for buildings or rooms. Rule of thumb, if it's 50 people, or actually less than 50 people, you only need one exit. So the classrooms, if you have a small classroom and there's maybe 20 students in it, that only needs one student. The auditorium areas where they have more than 50 people, you're going to need more exits. So that anything above 50, you'll need 2 exits. From 50 up to 500 people, you'll need 2 means of egress, or 2 exits. Then when you get from 501 to 1,000, you will need 3 exits. And then obviously from 1,001, you will need 4 exits from a building. but that's usually a rule of thumb, and you'll have to see that it is in the code will dictate those actual requirements. And that is the same for storage with one exit. The exit travel distance is measured on table 1016.2, and the table will indicate the use and the length of travel. So by example, if this was a business use, it will require that the person at any point in the building cannot travel more than 200 feet before they get to an exit. So if you get into a sprinkler system, then that is going to be increased to 300 feet. Again, the sprinkler system is a friend of the code that allows you to make a bigger building because you have protected the occupants and the structure for a longer period of time. So that's just a rule of thumb. Now your exiting, by the way, is measured in perpendicular path of travel, not on a diagonal as it used to some years ago. When you are also talking about exits, you need to get into its remoteness and its location. If you take a building or a space and you determine this diagonal distance, it's D, and let's say it's 300 feet, and you have an occupancy load of, let's say, 300. It means you have to have two means of egress. And it doesn't make any difference what the configuration of your space or building is. What they ask is that you take the diagonal distance from the most real points of that floor plate and draw a line to it and determine that distance. And then you have another door. And the way the code is written is that from that door, and those doors, meaning the center lines, that distance cannot be any less than, if it's not sprinkled, the distance divided by 2 or half, or if it is sprinkled, the distance divided by 3. So if you sprinkle the building, if it's not sprinkled in the building, those doors have to be 150 feet apart. If you are sprinkling the building, they only have to be 100 feet apart. And again, the same thing applies. If you need 3 exits, you still have to meet the requirements of the remoteness of the doors. The other items in the code: minimum height on ceilings, 7'6". The code also addresses, we talked a little bit about the American Disabilities Act and Barrier-Free Design. One of the key components of that are doors. And sometimes people mess up on doors. So let's understand what the code says about doors. A door, by its definition, has to provide a 32-inch clear opening. That's not the size of the door. That's the clear opening of the door. When you have a door, and if it's 90 degrees position, because it has a door closer on it, you have the thickness of the door to take it out and the stop. To accomplish that, that's why you have 36-inch doors, because they will give you 32 inches of clearance. It also requires that the maximum, and when you start determining the occupancy, it's a multiplier on the code of either 0.2 or 0.3. The 0.2 is the typical requirements for exiting. So if I have a 32-inch door, How many people can I get through that door? Well, it is a multiplier of 0.2. Simply divide that into that and you will get 180 people. I'm sorry, 160. I wrote 100. I saw 160 and I wrote 180. My mistake. So that code allows you to have 160 people through there. So that means in this case, if I have a 36-inch door, I can get 160 people in here and 160 people out of here. So what do I have for a total? 320 people. I'm good to go. If I happen to have a dimension, if I happen to have, what do we determine? I erase it. I have 300 people up here. If I happen to have 400 people, I may have met the remoteness requirement, but guess what? I don't have enough doors for the exiting capacity. So I'm going to have to add another door here to pick up the other 100 people or 80 people that I can't pick up. So I gotta somehow able to deal with 400 people coming out of this space, not 320. These two doors don't have the capacity. Or if I wanted to, I didn't have to add that one, I would have to add maybe a double door here. And it would be just twice the size of it. So I'd just have to add more doors. The swinging of doors, the maximum size of the door, well, first of all, egress doors have to swing. Secondly, the maximum size of the door is 48 inches as a swinging door. And it has to do with the ability for a small child or a very old person to move the door to swing in the direction of egress. And depending on the approach of the door, you're going to be required to have what's called a latch side clearance. How many inches is between 0 to 24 inches from the latch side, whether it be from the approach side or on this other side. And it depends on if you're coming in this direction or this direction. There's actually a chart in the code that you have to examine it and determine which way is your action, determine how much of a latch side clearance that you need. And the minimum height of the door is 6'8". But most commercial buildings use 7-foot doors. The 6'8" are primarily for residential type structures. The corridor widths are also the same thing. How wide is a corridor? Well, a 36-inch corridor is the minimum size you can have, and that is for 50 people or less. Once you get above 50 people, your exit width minimum is 44 inches. In educational, the requirement, because it is a K through 12, is the minimum corridor width on a school building is 72 inches. But you need to go through and compute the actual widths on the capacity. If you, by example, if you take a look at, this is for also, this is not just for schools, and for hospitals, it's 96 inches. And that's because patients are moving in and out in beds. And they want to be able to get 2 beds side by side or crossing, which are 44 inches. As they come up with the 96 inches in allowances. Also, the dead ends, if you have a building, and this is the corridor, the code says that you can't have a dead-end corridor more than 20 feet. And here's your outside wall. And what, I don't know, I've heard they did studies where the fire department actually measured the time, the elapsed time that was lost if somebody was running down a corridor in an emergency situation, whether it be a fire or some other emergency, and they turned the wrong way and they went down this dead-end corridor. They determined they could lose 7.5 seconds and not affect their life safety. So they determined they were backwards in that and said, okay, you can't have a dead-end corridor more than 20 feet. If you sprinkle the building, that dead-end corridor can be increased to 50 feet. Otherwise, the occupants would go down this. Remember, you're dealing with people that are going to be in a panic, and in a panic, you don't think in rational terms. You're going to have to be moving quickly, and your reasoning is not always there. Also, the corridors, the means of egress, the stairs, all these exit components may require a rating on it, anywhere from 0 hours up to 3 hours. And it all is dependent on the use. And if you sprinkle the building, then you don't need any of these requirements. Sprinkle the building, you require 0 hours. Again, that's obviously a big add to a building safety, is to have a sprinkler system. Another one that is a little bit of a mystery to us in the beginning are stairs. Stairs are different from residential versus the non-residential requirements. The stairs require that they're minimum, like corridors, if they're 36 inches wide, at less than 50 people. If they're greater than 50 people, then they are 44 inches wide. There's nothing in between. When then those are determined by the width, by the multiplier of 0.3 per inch. Where the corridor, if you remember, was 0.2 per inch. It's a matter of dividing that into the width, and a 44-inch corridor, you can have 147 people can traverse that stairs. If you have more than that, then your stairs become wider. 5 feet, 6 feet, 8 feet. Whatever you have the capacity for to deal with the number of people that are there. Headroom like a stairs, like a door, is 6'8". But you have to remember how the headroom is measured. As you take a diagonal along the nosing of the stairs and you measure it vertically. And that height minimum is 6'8", and again, that's called the headroom. And it's measured vertically. Other type, treads and risers. The tread, this is the tread. This is the riser. This is the nosing. So the tread is measured from nosing to nosing, and the minimum is 11 inches. The rise is 7 inches maximum or 4-inch minimum. Again, this has to do not with a 20-year-old college student that can probably take 3 or 4 of these steps at a time. It's dealing with young kids and old people. They've determined that the height for a little child or a very old person shouldn't be any more than 7 inches that they have to raise their leg up. And if you get anything less than 4 inches, it becomes a very awkward step. Also, in a stairs, that you also have to deal with a handrail. And the code requires that a handrail, again, if it's 36-inch wide stairs, a handrail only to be on one side. If it's more than 36 or 44 inches, it has to be on both sides. And the handrail is between 34 and 38 inches from, again, the nosing or the diagonal line of the stairs. That's why most handrails are 36 inches high. And furthermore, it requires that a handrail extend from the top riser 12 inches horizontally And at the bottom, it requires that it extend one length of the diagonal of the tread, and again 12 inches at the bottom. This is intended for people to be able to, older people and kids, that they really use the stair to guide themselves up and down. So it has to be able to be utilized in a fashion that allows them to move up and down the stairs safely. Also requires that anytime you have an open-sided floor, or even including the stairs, that you have a guard. And this is a handrail and an open-sided floor. You have a guard, and a guard in this case is 42 inches high. It's above the waistline, so if you happen to bend over, you don't fall down to the floor below. That's the origin of the 42 inches. Another aspect of the code, we talked a little bit about it, and that is the fire-rated construction. There are two tests you should be familiar with: ASTM E119 and ASTM E84. ASTM E119 is an assembly test. By the way, ASTM is for the American Society of Testing Materials. It's an independent organization that will do tests on these. And by example, if you have a wall or a door that you want a fire rating on, you will pay them $50,000 to test that door. It's independent. It's either going to pass or fail, but it'll give you a rating. The construction is rated anywhere from 20 minutes, or sometimes referred to as a 1/3 hour, a 1 hour, 1.5 hour, 2 hour, 3 hour, or a 4 hour rating. And the code will dictate when you have to have those types of rating for the construction. This is an assembly test, and that is in hours. Okay? And the assembly is something, let's say, like a wall. And what they do is they take a 10 by 10 wall and they construct it, and then they have a whole series of gas heads, and I believe that they are 12 inches away from the subject material, and they ignite these gas heads and the fire starts. And on the other side of the wall, they have a thermostat, and they measure the temperature. Once that temperature on the other side of the wall reaches 250 degrees Fahrenheit, the test is stopped and it is ended. And they measure the length of time from once they ignited the heads to the time it reached 250 degrees. And they time it. So if it happens to be 1 hour and 20 minutes, guess what? It gets a 1 hour rating. You have to meet or exceed those next milestones. And the other option, another condition if it fails, is the wall actually fails, or it moves, or does any other such item. The next test, let me back up. The Underwriters Laboratory, UL, is another independent testing agency, and there's actually 7 around the country. University of Michigan has its testing lab, and they're certified by Underwriters Laboratory to actually make these fire tests, and they will certify them and give them a rating. By example, one in the book on page page 15 shows that it's a UL A814, and it'll describe all the materials and the component of that construction, and therefore you have to duplicate it on your drawings to achieve that particular rating. This deals with, the code also discusses things like fire walls, fire barriers, fire partitions, smoke barriers, oops, excuse me, getting ahead of myself. And also smoke partitions. I won't get into all the little nuances of this. Basically, firewalls are to separate buildings, and they're independent structures that allow collapse of a building from one side without affecting the collapse of another building. And those vary anywhere from 2 hours to 4-hour construction. And fire barriers are typically barriers in corridors. Fire partitions are separation of spaces or occupancies. And smoke barriers, like the name implies, they're a matter of preventing the spread of smoke from one space to another. And these are all defined in the building code. I won't get into too much detail. We talked about the sprinkler building, and that is the fire protection that we were talking about, that the code so much loves. And so what they've done is they've required that certain types of buildings, or excuse me, certain uses require that it be sprinkled. By example, if you have an A2 use group, which is a restaurant, and if you exceed 100 occupants or 5,000 square feet, you have to sprinkle that space. Same thing applies with other types of uses. So the code is very definitive, where it has certain restrictions. When you achieve that, you're going to have to sprinkle the building or that space. And it's not a partial, it has to be the whole building. They don't allow you anymore in the code. They used to just sprinkle one room if it was the assembly use. Now they need the whole building sprinkled for that. Sprinkler systems are both wet and dry. The most common one is a wet sprinkler system. They use dry ones in an area like in freezers or in loading docks that are enclosed, where that it has to have mechanisms that trigger the alarm that will send the product through the pipe and out in case of a fire. The other ASTM test that we need to talk about is ASTM E84, which is known as the tunnel test. And that is actually the test of a material. The code will require that you have a flame spread rating, excuse me, try and say that real fast, of Class A, B, and C. Class A rating is from 0 to 25, and B is from 26 to 75, and C is from 76 to 200. You don't have to worry about that other than to look at the material label on the material you're specifying and make sure it meets one of those requirements. The manufacturer is responsible for testing that and putting that label on that material. It's not your responsibility as a design professional, but it is your responsibility to make sure what you are specifying that it meets that requirement. So we have to look at those labels when you do that. It also gets into the smoke development, and it has to be from 0 to 450. And again, the label of the material will have that, so you don't have to guess that. It'll say it under past the smoke developed, or the maximum smoke developed is under 450. Or it'll tell you, this is a Class A material, Class B, or Class C material. The reason that's important is because you have to go to the code to determine all of that. The last piece of what the tunnel test is, in fact, a tunnel. And what they do is they have these tunnels. And they're 25 feet long, and they have these windows on them. They are 12 inches wide and 18 inches high. They place the material to be tested on the ceiling of that tunnel. And at this end they have a gas head, and at this end they have a fan. The test starts, they ignite the head, the flame goes in, the material starts to burn. And on this end there's a fan that is pulling out the smoke. The tunnel test is based on the 5.5 minutes, and what they use as a benchmark is red oak, which they arbitrarily assign a value of 100. They couldn't assign anything else. They had determined that concrete or asbestos is 0. So they're from 0 to 100, where the red oak burned for a full 25 feet, and they gave that 100. I'm sorry, it burned to 5.5 inches, and they measured that as equivalent to 100 as a ratio. The other item with that is the carpeting. Didn't talk about that, but carpet is a pill test. And what they do with carpeting is they take 8 samples, they're 9 inches by 9 inches, and they have an actual pill. They set it in the center of that 8 by 8 sample, and they ignite it, and they watch it burn. If of the 8 samples, 2 exceed 3 inches, the test is ended and the carpet fails. So you don't have to worry about that again. You'll see the carpeting will state that it passed the pill test. If it doesn't pass the pill test, you can't use it in commercial buildings. I did want to back up for a minute and talk about this flame spread rating, because one of the charts that's in the code is related to that. Table 8039, what this talks about is the wall and ceiling finishes in occupancies in different components of buildings. So again, we go back to our 10 groups here that are listed. We have a sprinkler building and a non-sprinkler building. You have exit stairways, you have corridors, and you have rooms and spaces. So what that does is these numbers here will tell you which one of these classifications that material and that wall have to be, whether it be a class A or B or C. If you notice in a stairwell for an A2, a restaurant, if it's not sprinkled, it has to have a class A rating. If it is sprinkled, it can be a class B rating. In other words, it has a greater flame spread rating. So again, it's the benefit of having a sprinkled or non-sprinkled building. And again, you have the uses that just match the actual space with this. You'll know whether it's sprinkled or not sprinkled, and you come up with the requirements of the surfaces of that wall. One last item that we'll talk today, and that is in regards to the structural requirements on buildings. You'll have a good deal of input on this because you are designing this structure, and you need to pass on that information to your structural engineers. But you should be familiar with some of the major components in the building. Okay, live loads. Live loads are determined by the code. They're in a table in the building code, and that's table 1607.1. And so it'll tell you, what kind of a use is it? And let me find one here for you. By example, it'll tell you for corridors in office buildings, the corridor rating has to be 80 pounds per square foot, where the office area would only have to be 50 pounds per square foot. Storage of materials, minimum is 125 pounds per square foot, etc. Dead loads, those are basically determined by you and your engineers. Live loads are any movable items in a building. People, furniture, equipment, something that's not physically bolted down. Dead loads is the actual structure. You have a 4-inch concrete slab, you have the structural steel of the beam, you have the roofing, the insulation, the metal deck, the ceiling, the light fixtures, the sprinkler systems, all of that are dead loads that's assigned to the building. Snow load is like the name implies, it determines the number of snow capacity, and it varies. Snow loads anywhere from 20 pounds a square foot to 90 pounds a square foot, as you find in the upper part of the Upper Peninsula in Michigan. Rain, there is a chart, and these are all given up in charts that you'll see in the code book. Rain is determined by inches of rainfall. So you have to design for the roofs of that. Wind, the majority, that has been recently updated because of the hurricanes they had in Katrina in the Gulf. And now we have to design all buildings for 150 miles per hour. Where prior to that, it used to be 95 miles per hour. And I guess that because of that tornado, or I'm sorry, not tornado, but the system that came in, it had effect inland. So they jumped it up by 20 miles per hour. Earthquakes, don't have to worry too much of that. All there is minor requirement in the southeast part of Michigan. But there's certain parts of the country you have to do. Dynamic loads, those are loads such as elevators and crane rails that have a force and then immediately stop. So it causes motion in the building that you have to deal with. But all of these requirements are primarily found in the page in the chapter 16 in the building code. One of the other things that they look at in buildings when you compute all this is the risk factor. And it has different categories. A 1, a 2, a 3, and a 4. You have to put your building in one of these categories. A type 1 is a low hazard, like agricultural buildings. Type 2 are all others. Type 3 are hazardous to human life. Things like large buildings, movie theaters, large assembly groups. Essential facilities would be hospitals, it would be fire stations, it would be police stations. So they have a different requirement, and there's a multiplier in one of these categories as it relates to all these other structural requirements. That will end the presentation today. I hope I didn't scare you too much about the building code, but it's important that you understand the code, otherwise you're going to be constantly redesigning the building because the building department will reject your plans when they submit it for building permits. So, thank you.